Hello and welcome to episode 118 of Linux Dev Time. I'm Joe.
I'm Kevin.
And I'm Andy.
Good to talk to you both again. No Amaleth this time, he's a little under the weather, but hopefully he'll be back next time. There's been a lot of drama around the Linux kernel and specifically Rust in the Linux kernel. This has been going on for over a year at this point, and it seems to be really ramping up lately. So I wanted to get your take on it as two Rust developers. I know you're not kernel developers, so let's make that caveat, but I kind of want to try and understand the technical arguments that are happening at the moment. So who's going to explain this to me?
So I think before we start out, one thing we should note is that the Rust for Linux project, R4L, RFL, however they want to say it, it's been going on now for, I think, a few years, and it's still in the experimental phase. Regardless of some of the more recent drama that's happened, it is still an experiment, and what my understanding of it is this is meant to be device drivers, and let's see how well we can integrate a second language into the Linux kernel, because the kernel has historically been C only, not even C++. There's been massive amounts of either drama or pushes to try and get C++ in, and that's always been a hard no. So this would be the first second language that would go into the kernel. But it's been in the experimental phase to see, is it worth it? How can we do it? How do we add a second language? And there's been a very hard line about we cannot force Rust, as in you should still be able to build a Linux kernel that is just C only. The Rust pieces can only be optional. So that's the phase that we're kind of in before we even kind of step into the dramas. This is purely an experiment, and it is a kind of opt-in thing.
As well as there being this rule that you should be able to still build a working kernel without Rust, just with the Rust bits missing. There also seems to be a rule that maintainers who don't want to have to deal with a second language shouldn't have to deal with it as well. And that's closer to where some of the controversy is happening, I think.
Yeah, there's been some, I don't know if it's more of a social kind of political issue, but the Rust for Linux maintainers have been very adamant about, hey, we are not forcing anybody to learn Rust. If you don't want to learn Rust, you don't have to. However, there are certain pieces that are going to need to interface with the C parts naturally. So what has been said thus far is that the Rust for Linux maintainers would create the bindings or whatever sort of bindings or APIs are required to interface with the C parts, and they will be responsible for those. The C developers do not need to even care about that, as in if they break the Rust bindings, that's on the Rust developers to fix. Now, that argument hasn't necessarily gone over super well with some of the C developers who have said, I don't care if you're saying you're going to maintain the thing for me. The fact that it's still going to break and that I don't have the ability to fix it myself unless I learn this other language, that's rubbed some people the wrong way.
Well, yeah, and also surely if you don't know Rust, how can you know that that particular bit of code is doing what it's supposed to be doing? I'm not saying it's going to be nefarious, but how can you tell things like the quality of it?
Yeah, I think the idea is that the people who don't want to learn Rust just don't even have to think about that Rust code. They're just not responsible for the quality of that bit of code. This is all very well in theory, right? That you just go ahead and write your C and we'll kind of wrap Rust around it and you don't have to worry about it. But in practice, two things are happening. Number one, some Rust people are asking for changes to the C to make it easier and make it fit better with the way Rust thinks. And number two, when they're asking, sometimes they're asking in a bit of a rude way because they come along with things like, your C was never right anyway, that's why we need changes. And that has definitely rubbed people up the wrong way.
Well, isn't that one aspect of it that C is rubbish, it's not memory safe, Rust is, therefore it should be completely rewritten in Rust eventually?
So I don't think anybody is saying to completely rewrite these parts. What I have seen said in the different mailing lists is there are sections of the C code that are effectively impossible to use safely and correctly. Now, a lot of these parts are either not used currently in critical sections. So, for example, I want to say there was something in the DM shed section. However, I've never actually said that out loud. So it's the DM_SCHED. Anyways, in that section, right, there are sections where you cannot properly use the pointers effectively. However, right now it's only used in shutdown code for GPUs or something. However, something like the Asahi Linux project actually does need to shut down GPUs dynamically. And I think they do like one per application. So they end up running the shutdown code, not when your computer's rebooting, but all the time. Additionally, there's things like eGPUs, which I've heard are notoriously bad on Linux. I haven't personally tried one, but it's for this exact same reason. So there are parts of the C code that are effectively impossible to use correctly. So that's where some of I think the comments have come about that say like, hey, this thing didn't really work in C anyways. Is there a way that we can make it work correctly in C, but also work for Rust?
I think it's worth coming on slightly now to why did Rust get allowed, right? So why was C++ not allowed? Why is Go not suitable, or Java or some other programming language? And I would characterize it as Rust has like two things going for it for Linux kernel development. One is that you can predict its behavior. You can look at the code and understand how it's going to behave in a way that's similar to C and maybe is not quite so true of some other languages. And two, that some of the ideas in Rust are actually kind of codifications of things that people already do on a social level when they write C. So the reason why these things are in any way compatible is because often you can write Rust code that encodes a behavior that was already like documented. You have to do it this way in C, but it wasn't enforced by the compiler. But with the Rust code, it is enforced. That means that you then have to clarify things and make sure that you're being absolutely correct in the way that you say, this pointer is owned by this person or whatever type of thing it is. And that's where some of the arguments that the code is currently wrong come from.
Exactly. That's also where some of these other arguments around documentation of the existing C APIs has come into conflict with some of the Rust developers. And that's because the Rust developers have said, hey, we want to wrap this C code with safe Rust code. However, in order to do that, we need to know the semantics of the API that we're wrapping. And there has been some drama around the C developers either being unwilling or unable to define the semantics in a way that the Rust developers can encode them. So sometimes that's because the semantics either are just inherently unsafe and there's just you have to do it this way and that's just not something you can encode into a type system. Or it's because some of them have admitted, we don't know the semantics for this API, so we just kind of have always got lucky and not hit one of those edge cases. So there's kind of those two battling factions of like, hey, can you document these APIs so that we know how to properly encode them, and others saying, no, we don't know what they are, so no.
But I'm getting more and more aware that there are two people who really quite like Rust talking about this battle between people who like C and people who like Rust. And we should talk about the other side, right? So the way I see the other side of people who are very annoyed with this whole thing is partly about that arrogance that I mentioned earlier. But it's also that if someone is a long-term maintainer of a very complicated and difficult C code, and they've been successful in the Linux kernel community because they really get that whole area, and it's really difficult stuff, and every detail matters. And now someone's coming along and saying, in order to satisfy me because I think my thing is better, you need to change how this works for no good reason from your point of view, just because I'm telling you it's wrong. That must be very irritating, but also feel risky to that person who is on top of everything and doesn't want to change it for no reason.
I haven't necessarily seen, obviously I haven't read all of the mailing list, but I haven't necessarily seen a lot of the Rust developers asking for deep C changes or changes to the C API in order to benefit Rust outside of the small instances where they say this is not correct in C anyways, and no one is using it correctly in C. Therefore, like it should be corrected on the C side for the benefit of the C developers, not just for the Rust side. I haven't necessarily seen them say like, hey, this doesn't work for Rust, please change it for us. In fact, I've seen a lot of the opposite of that where they've been trying to say, hey, we will wrap, we will extend, we'll do all these other things so that you don't have to care about what we're doing. However, in order to do that, we need to encode it safely. I do see how a C developer who's been working on this for a long time, like absolutely, like this could be seen as a, kind of takeover event where like, why is this other developer coming in? And Rust developers do kind of have a tendency, I would say, to get overzealous at times, especially about some of the safety aspects. So I can see why there would be animosity between the two groups. However, I also don't think that the C source code in the Linux kernel is top notch. And this is by their own admission, right? This is not me jumping in and saying like, hey, this code is no good. a lot of the existing maintainers will say things like, yeah, we don't know how this works, or this was written by a bunch of people who had no kernel development experience, and it was just a get it in and get it done. And now we've had a bunch of bugs because of it. Like, there is a lot, because there's so many different developers and different types of developers, the C source code inside of the Linux kernel is not, I would say, like NASA grade quality.
And it's a massive, massive project as well, right? Like, it's one of the bigger open source projects.
Yeah, so there's lots of it, and it's very, very complicated. And you've got these people who have like control of their area and really, really understand it and understand which bits are risky. And they're used to thinking at the grain of like less than one line of code. That's the level that they're thinking at. That's where problems might occur. But then someone's coming along and saying, but I want to write some part of this in a language that you don't know, that is very different from what you're used to, and is a much bigger language in terms of how much you need to know to understand it. Rust has a lot more reading and understanding you need to do before you're on top of it versus C. So I can definitely see that argument of why are people coming in, pushing me out of my area with something that's way harder for me to understand when my whole job is to understand everything.
I would say if that's what was happening, I would also agree with that. I don't think that they're trying to push out the C developers. I've seen people putting in additional device drivers in Rust, some of which have had some pretty high success, and then also wrapping of existing APIs in order to be able to call in Rust. So I haven't necessarily seen like, let's replace this key component of C with something in Rust.
Yeah, I'm trying to give like the perception rather than I don't think that's happening now, but I can imagine it happening, and I also think that it could feel like that to someone who's in that position.
Well, also, the kernel is like 30 years old, right? And it's had 30 years of being written completely in C. And so you can completely understand why some people don't want that to change. Even if Rust is going to make things better in some ways, write a new project. Go and do your new fancy stuff. Leave us with the crusty old kernel in C. It seems like a reasonably easy to understand position, even if you don't necessarily agree with it.
Yeah, and I think that gets to some of the more recent drama where certain maintainers have said that any multi-language project is a problem. And they're opposed to any language other than C, not necessarily because it's not C, it's just because it's a second language. They're opposed to any second language at all, because multi-language projects do have issues, or they have additional issues, additional hurdles that you need in order to properly maintain the project. But even with that, I've heard the argument a lot lately of, well, all right, Rust for Linux developers, you know, if you think you're not welcome here and you want to do your thing, why don't you just go make your own operating system? And I think that's like a little bit of a disingenuous argument, because the whole point is not to like have a brand new OS in Rust. I mean, there are projects like that, but no, I don't think anybody is seriously taking those as a like daily driver Linux style replacement, right? Linux runs the world. That's what the applications are developed against. That's what people are using. And that's what people want to, in either, whether it be in their perception or not, they want to make better. They want to have fewer bugs, fewer CVEs. They want to bring in some newer developers who are probably, I would say it's easier to find a newer Rust developer right now than it is to find a older C developer.
Yeah, you can say younger people, that's fine.
I think that is a really compelling argument for why having Rust in Linux is really good, right? Other than it's new and you might get new people, I also think if you design your Rust in the right way, then the compiler can stop you creating some bugs. And that means if you're writing a driver and this is the first driver you've written for Linux, the compiler might help you not create a bug that you would otherwise have created. And that is good for everyone if it doesn't have other downsides.
And not only that, there's also potentially future optimizations that can happen, because either A, you're programming in a different style because you don't have the same worries of like multi-threaded contexts, but the compiler can take advantage of like knowing that certain pointers are not used in certain ways. So there's all kinds of additional optimizations that could happen. Now, they don't necessarily happen in Rust today, even outside the kernel, but these are all possibilities that are unlocked by moving to a language that kind of has these safe semantics from the compiler level.
Now, another thing that I've heard is that some people complaining that the Rust that's being used in the kernel is not like normal Rust. Do you know anything more about that, Kevin?
Yeah, it's definitely not, I would say, it like idiomatic Rust. There's some nightly features that have been enabled. There's also some different semantics that are required by the kernel that are not necessarily required all the time when you're writing Rust outside. So for example, there's things like you can't panic in an out of memory context when you are the kernel, which is what Rust will do by default. So there's different things like how do we handle out of memory errors without panicking? I don't know all of the different like nightly features that they have enabled, and I know there's a few of them, and they are working to get those stabilized into a stable Rust that can then be used in kernel development. But yes, it's not traditional Rust as you would see in like 99% of projects across GitHub or GitLab or anywhere.
Yeah, and things like that memory thing, it has knock-on effects because almost everything you can do in the Rust standard library might allocate some memory, and then it might panic, and you're not allowed to do that in the kernel. So then you're not allowed to use any of the standard library that you would normally be using in Rust, or you need to use a modified version of it. So it does sort of diverge a bit from your standard stuff.
And I think it also has to do with like custom allocators and how you specify those versus a global allocator. Like there's all kinds of like different minutia that are involved with the Rust for Linux variant of Rust that's being used in the kernel. But either way, I mean, you're still getting those underlying principles and those underlying like core benefits of Rust. And I think that's why this is even being entertained as an experiment in Linux, is it really does bring in some tangible benefits, or it could bring in those tangible benefits in the long term. More safety, like more performance.
When I first heard that Rust was going to be allowed even as an experiment, I was really shocked. I thought after the controversy about C++ and the insults about C++, I thought there's no way another language is going to be tolerated. But it goes to show that, I don't know, it either goes to show that Rust is very compelling, or that people base their arguments on the evidence rather than just on emotional feelings.
Is it being tolerated though? I mean, it seems to be by Linus and Greg KH, but there are certainly maintainers who are just not having it.
Yeah, when we're getting into the more specific drama that's happening more recently, I would say there are several either core maintainers, lieutenants, kind of however you want to define them. So in Linux, I guess there are maintainers that will maintain like their particular subsection or subsystem of Linux, and they are kind of kings of that kingdom. They can determine what they want in that particular subsystem or not. The Rust for Linux developers will then come into those subsystems and say like, hey, can we add these bindings or these wrappers for your code so that we can call it from our drivers and our side in our little subdirectory of the world. And these maintainers have sort of full autonomy to say yes or no. Now, when in these cases like recently where they said no, there's still the possibility to take that patch and send it directly to Linus's tree and say, okay, the maintainer said no. However, there are other people saying yes, and we want this. What do you say as the final, like the official tree of Linux? And supposedly there have been some private conversations from Linus saying, yes, I'll go ahead and accept these patches anyway. But that hasn't happened yet, and we will see if it does.
And it's got even more complicated than that, because there's been arguments about whether the people saying no actually have the right to say no over the different bit of code. Maybe it's not actually within their remit and all of that stuff. So
this is specifically in the DMA subsystem of Linux, where the Rust for Linux developers want to add some bindings or wrappers in their directory, which is not in the DMA subsystem, but it would be the wrapper for parts of the DMA subsystem. And the DMA subsystem maintainer said, no, absolutely not. I will not accept this patch, even though it's in an it's in a different directory. However, it's related in the sense of it wraps his system. So yeah, it gets complicated, and it gets into like the politics of who owns what.
Okay, this episode is sponsored by people who support us with PayPal and Patreon. Go to linuxdevtime.com/support for details of how you can support us too. Patreon supporters have the option to listen to episodes without ads like this. And it's not just this show. There's Late Night Linux for news, discoveries, audience input, and misanthropy, 2.5 admins about system administration, Linux Matters for upbeat, family-friendly adventures, Linux After Dark for silly challenges and philosophical debates, Hybrid Cloud Show for everything private and public cloud, and Ask the Hosts for off-topic questions from you. You can even get some episodes a bit early. We've got a lot going on, and it's only possible because of the people who support us. So if you like what we do and can afford it, it would be great if you could support us too at linuxdevtime.com/support.
So I think from a technical point of view, the other thing that we should talk about is the actual Rust compiler and the Rust compiler version, right? So you mentioned, Kevin, that some sort of unstable versions of the Rust compiler are needed to do all of the stuff that's needed for this kernel development to work. And I think Rust has a more general problem that is quite difficult to package in a stable way, like to know exactly which Rust compiler version you're using and have that be compatible between different stuff that you're doing, because Rust is moving very fast and you often need the version that someone compiled last night off the internet in order to do the thing you're trying to do. And that worries me, even as someone who's an enthusiast about Rust. Like, how can we be really confident of the language we're actually using if it's based on a kind of unstable version of the Rust compiler?
That's right. I think we should define for the audience, like, how does Rust do development? So Rust typically has 3 compiler tool chains. They have the stable one, which is released every 6 weeks. There's a new stable compiler. Then there's a beta compiler that is effectively the stable +1 to see what new features will be coming down. And then you have what's called the nightly compiler. That nightly compiler is, as its name suggests, compiled every single night. Those unstable features, so features that have not been accepted into the core language yet, they have been proposed, sometimes they've been tested, or there are experimental implementations of them, those all go into the nightly compiler. That nightly compiler is the only place you can access quote-unquote unstable features. Now, some of these unstable features are unstable in name only, kind of. So some of these unstable features have been around for years. And the reason they're unstable and not accepted into the stable compiler is because there might be some edge case that they still want to catch or that they can't quite define, or perhaps there's some semantics they're waiting on. Maybe there's some other upstream feature that they're waiting on landing. There's all kinds of reasons a feature may remain unstable for even years at a time. My understanding is that the unstable nightly features that the Rust for Linux group is using is relatively small, and those features are also relatively well defined, as in they haven't had, even though they're quote unquote unstable, they haven't changed in a very, very long time. And they are on track to become stable. There are just additional details that they need to figure out or define or decide on. So that's kind of in general how the Rust language works. Now, most people work on like a stable toolchain, or they will work on nightly, but then deploy with a stable toolchain. And that sounds a little bit more chaotic, but what it in practice means is you can just pin a nightly compiler and compile on that one indefinitely, forever if you'd like. And that's what some people do in order to get access to the unstable features that they may need. Other people will use the stable compiler chain all the time and just update as needed. There's been some talk about like LTS style versions for Rust. That's been mostly shot down because Rust has very strong backwards compatibility guarantees. So whenever a new compiler is about to be cut, every 6 weeks, they will compile all known public Rust code against that new compiler with all the regression tests and see if anything broke. So that is all public code on like crates.io, including all versions, and they will have different regressions to show how many versions or how many of these crates have regressed, even compile times. Like there's all kinds of testing that goes into these new stable versions. So they're extremely strong backwards compatibility guarantees, which allows people to stay on that kind of stable train moving forward every 6 weeks. Now that sounds hard, but it also means that like there's not these major cutover releases like a Python 2 to 3.
Yet.
Yes, yet. There's always a new release happening every 6 weeks. So if your pet feature doesn't make it in, well, in the next 6 weeks, it might. So there's never any like super big rush to get these features landed in a particular version of Rust.
That's all great. And that backwards compatibility guarantee in practice for me has worked beautifully. And I think it's amazing. But if I were an outsider listening to that and I was used to using a GCC version that I update every 3 years or something, and suddenly now I've got a release every 6 weeks and I'm not even using the stable releases, it just feels like a different approach that would require to win a lot of trust from me before I was okay with it.
Yeah, so in that scenario, right, let's say you are used to using a GCC that you update every 3 years, and now you've switched over to Rust, and there's a particular nightly feature that you need, so you have to compile on the nightly compiler. Most of the time, what I've seen, people don't use a nightly compiler and then update every single night. They pin the nightly version, and then they will update that nightly version every 3 years. That's pragmatically what happens, right? So it's not quite as dramatic. Yes, you could update every day if you wanted to. That would be, in my opinion, somewhat silly, but that is totally possible. Most people just pin a nightly version, and then they continue to just stick on that version. Now, that nightly version 2, that is a release of the stable compiler with the nightly features enabled. That's all it really is. So like when the new nightly after new stable is released, it's really just that same stable compiler with the nightly features enabled. There's not really any additional magic in there. So that's kind of what gives the people, not only do you get the nightly features, you also still get all of the backwards compatibility stuff that you've had from a stable tool chain as well.
But it's worth pointing out, it's super easy to do this, right? So you slightly modify your command line and then you're using the nightly instead of the stable. So I actually only use it to format the code, and the rest of the time I use the stable compiler.
And that's, I think, another thing that Rust brings to Linux, or really to a lot of projects, is just newer tooling. And I don't think this is necessarily inherently a Rust thing. It's just because Rust happens to be newer. So there are other languages that Rust was able to learn from. There's other tooling and tool chains that Rust was able to learn from and say like, hey, we like this, we don't like that. What if we did this? It just happens to be like newer practices. That's all. So, but these are still tangible benefits that come to projects and that people like using when they sit down to develop for something.
We've accidentally gone into just a Rust love fest.
Well, if we take it all the way back and we look at the C source code of Linux, which is obviously working, no one can deny that Linux is wildly successful with the code that it has right now. So why even move to Rust? I think there are plenty of subsystems, if not the majority of subsystems, that don't even need to think about moving to Rust yet. I think a win would be allowing new code to be developed in Linux in Rust, but leaving all currently existing code. And that doesn't mean you can't continue to use C for the things that are there. So there are things about Rust that are difficult. I don't think either myself or Andy would argue that Rust is an easier language to learn. I might argue that, like, although C is easier to learn, there's also so many different things that you just have to keep in your mind that you don't need to learn them, but you need to learn them in order to not have a security incident that Rust kind of holds your hand through. So there's all of those kinds of things. But from a language perspective, I don't think anybody would argue that Rust is an easier language to learn than C.
I would never think of messing with a device driver or something written in C or writing my own. But if I knew that I could use Rust to do it, I would be more likely to consider it because I know that the compiler is going to stop me doing many of the possible stupid things that I would otherwise do.
Yeah, there have been several programs in the past just for my work where, because I was using Rust, allowed me to do something that I would probably have avoided like the plague if I were writing this in something like C, just because I wouldn't have trusted myself to do this. And here I know like Rust is kind of watching over me, and that doesn't mean I can just code willy-nilly, but it does mean that I can do things in a multi-threaded context or in ways that traditionally in C would have been like wildly unsafe.
Yeah, there is some stuff that you can just do willy-nilly, right? Like, so there's certain types of concurrent code that I wouldn't attempt in a language that didn't have Rust's guarantees, but I don't really need to think about it when I do it in Rust. I just throw the code out there and the compiler says, nope, you've done that wrong, and it sorts me out.
Right, well, we better get out of here then. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Kevin.
And I've been Andy.
See you later.